Okay, this is part 3 of lesson 6.3. So now it's your turn to work on this. So I want you to graph the exponential function f of x equals negative 3 times 3 to the x power. I want you to state the a, b, and y intercept and state what the end behavior was. So try that on your own. Pause it and then come back. Okay, now that you've come back. So a couple things we can do. First thing is we can definitely identify some very, very simple things here. For example, A is very easy to identify from the original equation. A is going to be negative 3. And B is very easy to identify. It's going to be 3. So we're increasing by 3. And then the y-intercept is also extremely easy to identify. When x is 0, y is going to be negative 3. So we can, right from the get-go, we can plot that. When x is 0, y is 3. But then how about some other values? So let's just come up with a quick table of x and y values. So we'll do, we'll try negative 2, negative 1, 0, 1, 2. This should generally be enough to get us where we want to go. So if x is negative 2, that means we are technically doing negative 3 times 1 over 3 squared, which is the same as negative 3 times 1/9, which is going to give us, excuse me, it's going to give us negative 3/9, which is the same thing as negative 1/3. If we had negative 1, we're just going to get negative 1, and then 0 is negative 3. If it's 1, that's 3 times negative 3, which is negative 9. If we square it, 3 squared is 9, times negative 3 is negative 27. Okay, so we can definitely graph some of these values. So at negative 2, we're at about a negative third. At negative 1, we are at negative 1. And then at 1, we're at about negative 9. So you can quickly see how it grows or how it changes. Okay? And so we then want to state the end behavior. Well, as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches 0. Okay? All right. So let's do the same thing for the next one. Graph the exponential function f of x equals 5 times 0.6 to the x power. State what a, b, and the y-intercept are. So a, that's 5. B is 0.6. The y-intercept, well, when x is 0, y is going to be 5. Okay? And then I'm not going to do a table of values like I did before. You can do that on your own, but you can see what it would look like. So again, when this is 0, it's going to be 5. And then it down here tends to grow rather quickly. Okay? It's not the greatest curve, but you can kind of see where that's going. And so then state the behavior when x is approaching infinity. F of x is approaching 0. And when x is approaching negative infinity, f of x is approaching positive infinity. And these are some of the things that we want to think about when we're graphing exponential functions, where they're going, what are the top values, which generally go into infinity, or they tend to decrease as they approach 0.